Welcome to today's lesson, which is about exponential notation. The goals of today's lesson are that you can use exponents to describe repeated multiplication and that you understand the meaning of a term with an exponent. So, an exponent means how many times to use a number in a multiplication expression. So in the example here, we have 4 to the power of 3, or you could also say 4 to the third power. And the base is 4 and the exponent is 3. And so we multiply the base 3 times. So you have 4 times 4 times 4. And that's 4 times 4 is 16. And then that times 4 again is 64. So 4 to the power of 3 equals 64. Let's write 2 times 2 times 2 times 2 in exponential notation. 2 is the base. That's the base. And it is multiplied 4 times. So it's 2 to the power of 4, and 4 is the exponent. And we would, if you were to evaluate that, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. To expand expressions, if you're asked to do that, it means to write out how many times the base is multiplied. So the base is 5, the exponent is 3, so 5 is multiplied 3 times. 5 times 5 is 25, and then 25 times 5 is 125. So here we have 5 to the power of 2, or 5 squared you might hear sometimes, and that's 5 times 5, which is 25. The exponent applies to the number or variable directly to the left of it. So in the next example, we have negative 5 in parentheses to the power of 2, and the exponent applies to everything within the parentheses. So we have negative 5 times negative 5. And you know that multiplying a negative by a negative gives you a positive. So we get 25, positive 25. Now in our final example here, we have negative 5 squared. The base is 5 and the exponent is 2. The exponent does not apply to the negative, which is before the 5. It applies only to what is immediately to the left of it. So it's negative 5 squared is what you need to work on here. And so that's 5 times 5. It's negative 5 times 5, which is negative 25. So I just wanted you to see the difference there between negative 5 squared. When the negative 5 is in the parentheses, the exponent applies to everything within the parentheses, and negative 5 to the power of 2 here when there's no parentheses and the exponent only applies to the 5. So that's just something to watch out for. You can expand fractions. So we would have 1/5 as the base and 3 as the exponent. So that means multiply 1/5 3 times. And let's multiply across the numerator first. 1 times 1 times 1 is 1. And 5 times 5 is 25, times 5 is 125. So it expanded by writing it out like this. Powers of 10. Let's start with 10 to the power of 2. That's 10 times 10, which is 100. Then let's go 10 to the power of 1, which is just 10. Let's look at 10 to the power of 3, which is 10 times 10 times 10. 10 times 10 is 100, times 10 is 1000. And I want to point out to you that the exponent matches the number of zeros in the 10. So we've got 10 to the power of 1 is 10, just 1 0. 10 to the power of 2, when you multiply it out, 2 zeros. 10 to the power of 3, 3 zeros. And so when we have a large number like 1 million, which we have here on the left-hand side, that would be 10 to the power of, count the number of zeros, 6. So to summarize today's lesson, we can write an equivalent expression for repeated multiplication using exponents. So instead of saying, for example, 3 times 3 times 3 times 3 times 3, we could write an equivalent expression with exponents. The base is 3, it's multiplied 5 times, 3 to the power of 5. And in the expression 5 cubed, 5 is said to be raised to the third power. And we can say 5 to the third power or 5 to the power of 3. So you saw in today's lesson how to use exponents to write an equivalent expression for a repeated multiplication, and you understand the meaning of a term with an exponent. And that's the end of today.